So hypophosphatasia is caused by mutations in a gene called ALPL, and this gene encodes alkaline phosphatase. It's one of the 4 genes that encodes that. So the version that encodes that's expressed in kidney, brain, and liver is affected. So what happened is that alkaline phosphatase in the bone is responsible for converting a chemical called inorganic pyrophosphate, which should be converted to phosphate so that it can be used for hydroxyapatite formation, and then you can understand that integral part of the bone formation happens in osteoblast. So if the enzyme is deficient, it cannot promote hydroxyapatite, and further the substrate inorganic pyrophosphate is an inhibitor of hydroxyapatite. So by combination, if you don't have the enzyme, your bone formation essentially is impaired, so you cannot form a bone. So that's what happens in the bone. And further, it has a lot of function. The enzyme has a lot of function in other parts of the body, which is a lot of them is not understood yet. But what we know in the brain is that it's essential in converting the vitamin B6 from the form called PLP, which is a circulating form, into a form that doesn't have the phosphorus group, so it's lighter, so that it can cross the blood-brain barrier. So if that does not happen due to the deficiency, the brain cannot utilize vitamin B6, which is critical in a lot of the enzyme that happens in the brain. The key ones are the neurotransmitter biosynthesis. So long story short, if you don't have vitamin B6, you can develop seizures and other complications. So that's another pathophysiology in the severe end of the disease.